Encrypt and Decrypt using PyCrypto AES 256. I'm trying to build two functions using PyCrypto that accept two parameters, the message and the key, and then encrypt or decrypt the message. I found several links on the web to help me out, but each one of them has flaws. This one at Coder Koala uses os.urandom, which is discouraged by PyCrypto. Moreover, the key I give to the function is not guaranteed to have the exact length expected. What can I do to make that happen? Also, there are several modes. Which one is recommended? I don't know what to use. Uneasy face. Finally, what exactly is the for? Can I provide a different for encrypting and decrypting, or will this return in a different result? Edit. Remove the code part since it was not secure.
You may need the following two functions, pad to pad when doing encryption, and unpad to unpad when doing decryption, when the length of input is not a multiple of block underscore size. So you're asking the length of key? You can use the MD5 hash of the key rather than use it directly. More, according to my little experience of using PyCrypto, the for is used to mix up the output of our encryption when input is same, so the for is chosen as a random string, and use it as part of the encryption output, and then use it to decrypt the message. And here's my implementation.
Here is my implementation, and it works for me with some fixes. It enhances the alignment of the key and secret phrase with 32 bytes and 4 to 16 bytes.
For someone who would like to use YuleSafe_B64 encode and YuleSafe_B64 decode, here are the version that working for me, after spending some time with the Unicode issue.
Let me address your question about modes. ES256 is a kind of block cipher. It takes as input a 32-byte key and a 16-byte string, called the block, and outputs a block. We use AES in a mode of operation in order to encrypt. The solutions above suggest using CBC, which is one example. Another is called CTR, and it's somewhat easier to use. This is often referred to as AES-CTR. I would advise caution in using AES-CBC with PyCrypto. The reason is that it requires you to specify the padding scheme, as exemplified by the other solutions given. In general, if you're not very careful about the padding, there are attacks that completely break encryption. Now, it's important to note that the key must be a random, 32-byte string. A password does not suffice. Normally, the key is generated like so. A key may be derived from a password, too. Some solutions above suggest using SHA-256 for deriving the key, but this is generally considered bad cryptographic practice. Check out Wikipedia for more on modes of operation.
If you want to support the channel, please consider liking and subscribing.